of soil science, right? So in fundamentals of soil science, what have you studied? You have studied mainly soil forming processes, rocks, minerals, and mostly physical properties of soil, right?
Yes, ma'am.
Okay. So you know the different branches of soil science also. So we have soil physics, soil chemistry, soil biology, soil fertility, then soil conservation, soil technology. So all these are branches of soil science. So when you come to soil physics, in your PUC, you might have studied physics, chemistry. So what are the different aspects you have studied in in physics, not soil physics, in physics, mass, matter, force, etc. You might have studied. So similarly, application of those physics in soil, that is studying the mechanical behavior of soil, is referred to as soil physics, whereas soil chemistry is as the word chemistry itself will tell you, that soil chemistry is the study of chemical characteristics of the soil, and it is affected by the mineral composition, one, second, organic matter, third, environmental factors. So we know the volume composition of soil. In your fundamental course, you might have drawn that volume composition of soil, that is pie chart, wherein soil is made up of 45% of minerals, 5% organic matter, 25% water, 25% pores. So you know the composition of soil. So soil is considered as a three-phase system or four-phase system. Three-phase system means solid phase, liquid phase, gaseous phase. So in this course, you will be studying what are the various chemical behavior or chemical reactions happening between these phases of soil, and how these chemical reactions or behavior of soil making the nutrients available for plants, like mineralization will be there, then organic matter decomposition will be there, then absorption mechanisms. So all these include the chemistry of the soil. So in soil, what are the different components present? You know, soil is made up of inorganic components, organic components. So the major inorganic components include the rocks and minerals. And from the minerals only, we get all the elements. So various elements which are required for the crop growth are the major nutrients like NPK, calcium, magnesium, sulfur, iron, zinc, copper, manganese. All these are minerals. So how are these available for the plant growth? And organic matter, you know, organic matter decomposition has to take place, wherein certain reactions like mineralization helps in making the nutrient available. So this knowledge of soil chemistry mainly is used to improve the availability of nutrients to plants, and also sometimes to avoid toxicity of elements to the plants, then even utilizes soil microbial population and to improve the physical condition of the soil, then to improve soil stability, means it stabilizes the soil and also helps in reducing the pollution of the soil and water. So soil chemistry involves knowledge about the effects of reactions on the particle surfaces, that is on the soil particles, mainly the reactions that are taking place in the soil colloid, that is clay and humus, their solubilities and their microbial responses, interaction of nutrients. So soil chemistry involves study of all these aspects. So coming to the components of the soil or solid phase, soil is made up of sand, silt, and clay. So among these three particles, where do you think the chemical reactions will take place? Sand, silt, clay. So where do you think the chemical reactions will take place in the soil? Any idea? See, among sand, silt, and clay is referred to as the charged particle only. If clay is not present in the soil, no chemical reaction will take place. So the colloid is the most important particle of the soil, which is required for soil chemistry to happen. So there are two types of colloids in the soil. One is organic colloid and the other one is inorganic colloid. So organic colloid is the humus and inorganic colloid is the clay. So if both are not present in the soil chemistry will not happen because clay is charged particle. What is the charge of clay? Positive or negative? What is the charge of the clay particle? Negative.
Negative, ma'am.
Yes, negative. Because it is charged only, it can attract the positive ions for the absorption. So soil colloids are the most chemically active portion of the soil. Or in other words, we can say that clay is the seat of chemical reactions. So soil colloids are the most chemically active portion of the soil. Clay is the inorganic colloid. You should know the difference. And humus is the organic colloid, which is charged. Only if these two are present, you know that chemical reactions will take place. So for the chemical reactions to take place, what other factors are important? You know the volume composition of the soil. It has water and it has pores that is filled with air. So both are important for chemical reactions. Suppose we add any chemical fertilizer to the soil, and if it has the nutrient should be available for crop uptake, then without adding water, that will not become soluble or it will not dissolve in the water and it will not be available for crop uptake if water is not there. Like how when we have food, we also eat food. And if we don't drink water, do you think the food what we eat, the carbohydrates, proteins or amino acids is available for absorption by the body? No, that is why we need water also. And we need air, oxygen also for breaking down those molecules of food particles. So water is important, air is also important. So the volume composition of the soil, that is mineral particles, organic particles, water and air, all these four components are important for the chemical reactions to take place. So you know the importance. Now coming to clays, soil clays. What are the different type of clays? Today's introduction class, I'm just giving you a brief description of how this course is going to be. So soil clays, you know that clay is, so among sand, silt and clay, what is the size of the particle and which has a very less size particle? Is sand bigger than clay?
Yes, ma'am.
Size? Okay. What is the size?
0.2 mm to 2 mm.
Okay, silt? 0.02 mm to 0.002 mm. Clay is less than 0.002 mm. Clay is the smallest of all the three particles. So if smaller the size of the clay particle means the surface area will be more. So when we add anything to the soil, It is the clay particle which absorbs maximum amount of nutrients or water. Whatever we add, it is the clay which is going to absorb the nutrients. So coming to clay, clay is referred to as the active mineral portion of the soil, and which is colloidal in nature and crystalline. So generally this clay has three meanings. One, it is a particle fraction composed of any particles less than 2 microns or 2 micrometers with effective diameter. Second, it is a name for minerals of specific composition. Third, it is a soil textural class. So in your fundamentals of soil texture, also you might have done in the department in the laboratory, wherein you would have classified the soil. There is one class, textural class referred to as clay. So when we say clay, the term clay means it is the colloidal nature, size of the particles less than 0.002 mm. And third, it is a name of a textural class. So many materials of this clay fraction, example, gypsum, carbonates, quartz, these are all small enough to be classified as clay on the basis of size, but they are not clay minerals. So you should remember that the quartz or any other mineral, quartz, gypsum, carbonate, they cannot be considered as clay based on the size of the particle. Some clay minerals sometimes may have sizes 4 or 5 micrometers, and sometimes this upper size limit of the clay size fraction. So that they're all called as clay minerals. They are referred to as clay minerals or specific crystalline or amorphous composition of any size up to several micrometers. So then how did this clay originate in the soil? So how did they study the origin of clay in the soil? So 1 minute. Hello? Hello? Allah. So they study the clay and clay structure using X-ray diffraction method. So you should remember the method used to study the structure of clay is by X-ray diffraction methods. So clays usually before studying these methods, X-ray diffraction methods, clays were thought to be just similar to the primary minerals like small particles of quartz, feldspars, micas, hornblende, agoit. But after the study utilizing X-ray diffraction, clay minerals are known to have specific composition, and except for micas, they are not very similar to primary minerals. So clay minerals are mostly formed, crystals reformed from the soluble products of the primary minerals. So we know that sand, silt, clay are called as secondary minerals. They are formed from primary minerals after weathering of rocks and minerals. So we say clay is a secondary mineral. So removal of some of the soluble products by leaching from the clay forming solution will reduce clay formation and alter the kind of clay formed. So soils of certain regions that have hot, moist climates, here leaching does not take place because of poor drainage. So such soils will have large amount of primary minerals dissolved in it. Later, that mineral will crystallize to clays. So in hot, humid tropical soils, the percentage of clay is higher even to depth of 5 to 20 meters. And some clays are altered from primary minerals such as micas and biotite and muscovite. So these are biotite and muscovite, you know, that is white mica and black mica. So that is how clays have originated, means clays are originated from the primary minerals. The primary minerals like quartz, feldspars, micas. Once that is weathered, certain soluble minerals come out of those primary minerals, get dissolved. When they are soluble, they get leached out in certain regions, and in some other region, they do not get leached out because of poor drainage, and those crystallize into clay. That is how clay is formed. Coming to the nature of the clays, most clays are crystalline. Most clays are crystalline, means they have definite repeating arrangement of atoms of which they are composed. So we say amorphous means powder form. Crystalline, crystal. Sugar is crystal. Should we say sugars are crystals? Salt is crystal, what you use at home. So clays here are crystalline, means they have a definite repeating arrangement of atoms of which they are composed. So they are made up of planes of oxygen atoms. So these clays, how they are made up of? They are made up of planes of oxygen atoms with silicon and aluminum atoms holding the oxygen together by ionic bonding. So what is clay made up of? So usually clay is made up of one silicon atom, or that is called a silica tetrahedra, and aluminum octahedra means wherein a silicon layer one silicon layer will have two layers wherein aluminum will be present. So that is the structure of the clay. So usually we say clay are hydrogen aluminum silicates. So these majority are made up of, as I said, planes of oxygen atoms with silicon and aluminum atoms. You should remember that. Holding that holds silicon and aluminum together is ionic bonding. Ion means it has charge. Silicon is 4+, aluminum is 3+. So because of the presence of ionic charges, they are held together by ionic bonding. So like this, wherein attraction of positively and negatively charged atoms get arranged by 3 or 4 planes of oxygen atoms with intervening silicon and aluminum ions. Usually they make up a layer. So in today is only one introduction class, so don't get if you don't understand, you can ask me, and again I will be in the next class. I will show you the PPTs and explain to you so that it will be easy for you to understand. So generally I'm telling you what you will be studying in today's, this semester's course. So based on this, there are different tetrahedron structures, octahedral structures, and what are the various substitutions taking place there. So like isomorphic substitution, how it takes place in different type of clays like illite clay, montmorillonite clay, then vermiculite, chlorite, illite. So there are different type of silicate clays. Examples of clays means montmorillonite, vermiculite, chlorite, illite, kyanite. So montmorillonite means 2:1 type of clay. Means it has silicon in the center and two aluminum layers. That is layer silicate. Like that, we have 1:1 means kyanite clay, which will have silicon with one aluminum layer, that is tetrahedral structure. So like this, the silicate clays separately, you will be studying what each clay means. What is montmorillonite, what is vermiculite, what is chlorite, kaolite. Then sesquic oxide clays also are there, like metal oxides, hydrous oxides. Then after this, then you will be studying organic colloids, that is humus. Humus, it is the end product of organic matter decomposition. So once you study detailedly the structure of these clays, how they are formed, you need to draw all the structures also. In the future classes, I will be showing those PPTs and you can draw that also. Or when you come back, if there is an offline course, it will be easy than an online class, I think. But anyway, then you will be studying those structures. Then you will be studying the cation exchange mechanisms, how cation exchange mechanisms takes place on the clay surface. You know that cations are positively charged ions. So soil colloid is a negative charge. So these cations will get absorbed on the clay complex by exchange mechanisms. And these are similar to the fertilizer absorption. See, when a fertilizer is added, for example, if ammonium sulfate is added to the soil, how does ammonia get absorbed by the plant? That NH4 plus ion will sit on that colloid, which is having a negative charge required by the plant, will get absorbed. So that is how cation exchange mechanism, humus colloid, and there is various magnesium 2 plus, hydrogen plus, sodium plus, potassium plus. So all this aluminum 3 plus. So you should know the charges of the nutrients and the importance nutrient availability to the crop. Then you should be, there is another concept called as AAC, that is anion exchange capacity, wherein anions also will be exchanged, and this the CEC usually they may be based on pH dependent or pH independent charge sites. Then you will be studying the soil reaction, that is pH, the importance of soil pH. Then in the course outline also have given the different type of charges, like pH dependent charges, pH independent charges, and how does this get or formed. There are different scientists who have given the concept of this double layer, that Helmholtz double layer theory, Goy-Chapman double theory, then Stern theory. Then so all these are included under the inorganic component part of the soil. So all these reactions will take place on the clay complex in the inorganic part of the soil. Coming to that soil organic matter, though that soil is made up of 5% organic matter, it has a major role in soil chemistry, wherein it is that part of the soil which releases different form of acids. So when organic matter decompose, there are formic acid, acetic acid, malic acid, oxalic acid, tartaric acids, which are released. So acids are important for dissolving the nutrients which are not soluble in water. And the soil organic matter decomposition takes place because of the activity of the microbes, wherein they release enzymes and get themselves involved in the biological reactions. So various enzymes like urease, protease, cellulase, lignase, then phosphatase, sulfatase, galacturonase. Then what are the factors affecting decomposition of organic matter? Temperature, soil, moisture, nutrients, different textures, vegetations, etc. All these factors influence organic matter decomposition. So you'll be studying that. Then once the organic matter decomposition is complete, the end product formed is humus. So humic acid. So you will be studying the different properties of humic and fulvic acids. Then what are the uses of those humic acid and fulvic acid? How that is formed, humic acid is formed, how is humus formed? There are different concepts. There are around four concepts of formation of humic acid. Then coming to the soil reaction means pH. Soil reaction means how to express soil pH. What are the factors affecting soil reaction? So all these depend on the nature of soil colloids. Then percent of base saturation present in the soil. Various climatic factors influence soil reaction. Various oxidation reduction reactions in the soil also influence the soil pH of the soil. How to buffer the soils. For example, acidic soils, saline soils, alkali soils, all these are based on pH. So how soil reaction is important there. Then coming to the submerged soil. See, dryland soils and submerged soils. Dryland soils means water is not stagnated there. Then submerged soils means you have seen paddy soils, wherein paddy is grown in stagnated water. So the chemistry also will vary in dryland soils and in waterlogged soils. Why? Because see, in dryland soils, no water means more oxygen is present in dryland soils. Submerged soils are whenever you add water to anything, then oxygen will not be present or it becomes anaerobic condition. So there are aerobic soils, anaerobic soils. Aerobic soils are usually dryland soils. Anaerobic conditions exist in submerged soils. So you need to know the chemistry happening in those soils. See, the chemistry will differ. Means for oxygen, presence of oxygen, what happens? Absence of oxygen, what happens? So so that to measure that electrochemical changes in submerged soils, there is a particular unit that is EH. So you should know what is EH, what is pH. EH means redox potential. pH means negative logarithm of hydrogen ion concentration. Then in paddy soils, usually paddy takes up nitrogen as ammoniacal form of nitrogen, NH4+, whereas in aerobic conditions, the plants take up nitrogen as NO3 minus form. So you can see the difference there itself. NO3 is the oxidized state of nitrogen. O is present means oxidized state. NH4 plus, see, wherever H is present, it is said to be reduced condition. So NH4 plus is the nutrient ion taken up by the paddy plants in submerged condition. So there are various nutrients which are available in dryland soils and which are the different forms. For example, iron, Fe3 plus, Fe2 plus. So you know that Fe3 plus is the oxidized form of iron and Fe2 plus is the reduced form of iron. So like that, there are different ions. There are different ions which are available in dryland soils or in submerged soils. Then even sulfates, sulfate SO42 minus is available in aerobic submerged soils, absence of oxygen. So like that, there are various chemical reactions in aerobic soil and anaerobic soil. So in the soil chemistry course, you will be studying various reactions occurring in the soil based on the presence of the organic components of the soil or inorganic components of the soil. So you have seen that syllabus, right? I've sent the syllabus. Is it visible to you?
Yes, ma'am. It was visual, ma'am.
So just I'm giving you an introduction what you will be studying. Okay. So for the next class, detailedly, I will show that PPT and then it will be easy for you to read. And I will give you the notes also. Fine?
Yes, ma'am. Okay, ma'am.
And is it clear what I'm telling you?
Yes, ma'am.
And the reference books also, if possible, you just see Soil Chemistry by Kim and Tan. Soil Chemistry by Kim and Tan is available. Then by Chemistry of Soil by Bear, B-A-R, Bear is also there. Then for practical class, you will be, if you come here, you will be doing estimation of pH, EC, carbonates, bicarbonates, chlorides. So the different cations and anions present in the soil, you will be analyzing. In fundamentals of soil science, you only studied physical properties like bulk density, water holding capacity, then texture, structure, all those are physical properties. But in soil chemistry course, pH, EC, CEC, then individual carbonate salts like carbonates, bicarbonates, chlorides, nitrates. So like that you will be analyzing in the practical course. So overall, you know what is soil chemistry now. The difference between soil physics and soil chemistry, you know, no. Soil physics only it will study the mechanical behavior of soils. Means soil texture, soil structure, porosity, water holding capacity, bulk density. Whereas soil chemistry deals with the various chemical reactions that are taking place on the soil colloids like oxidation, reduction, carbonation, hydrolysis, hydration. You have studied all that in chemical weathering. Similarly, here, how nutrients are taken up by the plants, by what mechanism, cation exchange mechanism, anion exchange mechanism. So what are the various factors which controls the moisture, temperature, or any other factors? Okay.
Yes, ma'am.
Okay. Today's conduct. So from Saturday you have class, right?
Yes, ma'am.
So from Saturday, same time, no?
Mm,
12 to 1. Huh?
Yes, ma'am. 12 to.
So during that class, I will show you PPT so that it will be understand, because soil chemistry you need to concentrate on those structures of silicates. You know how to draw that rock hydral structure, to draw those textiles of kaolinite, montmorillonite, brucite. There are different types of clays. So you need to know that. How many of you in the class? Total strength?
Ma'am, 94, ma'am.
94, huh?
Yes, ma'am. All are present, ma'am.
Okay. You take that screenshot, no?
Okay, ma'am. Okay, ma'am.
You take that screenshot and send to me.
Recording stopped.
Ma'am, shall I put in group? Ma'am?
You sent? Okay. So Saturday I will same time link, so we can have that class one. Okay.
Okay, ma'am.
Okay, fine. You have class now or lunch break?
Lunch break, ma'am.
Okay, fine then. You can leave the meeting. You have sent that attendance?
Yes, ma'am. I have sent.
You're going to sports, right?
Yes, ma'am.
Okay, fine then. Okay, then you can leave the meeting.
Thank you, ma'am.
Any doubts you can ask me, or you can leave, join on Saturday.